The Internet of Things is a network of physical devices, vehicles, buildings, and other items embedded with electronics, software, sensors, actuators, and network connectivity that enable these objects to collect and exchange data. In 2013, the Global Standards Initiative on the Internet of Things defined IoT as the infrastructure of the information society. Coming up on the program, we'll talk with Intel Corporation's Director of Federal IoT Solutions, Tiffany Sargent, about how her firm is contributing to this transformational phenomenon in the federal sector. Engaging our industry stakeholders to inform the U.S. federal government on today's most innovative IT solutions. NITAAC proudly presents Solution Showcase. Hello, I'm Todd Schwartzrock. Industry experts expect the Internet of Things environment to grow to approximately 50 billion devices by the end of the decade. And this clearly represents an enormous opportunity for the largest chip maker, Intel Corporation. With us today, the Principal Engineer for Federal, Tiffany Sargent. Tiffany, welcome to the program.
Oh, and thank you so much for having me.
So we're so happy to have you on here. I want to understand your personal journey. How did you get involved in this fascinating field of Internet of Things?
Well, you know, it's a fantastic story. I started Intel in 1994, and one of the first roles I was assigned was to increase our ability to do gas and chemical forecasting better for manufacturing. And one of the things that we needed to do was figure out how to have more real-time data for decision making. And as we looked across our environment, we needed to really change our technology approach and really use some of the early techniques of data science to identify what kind of data we needed to collect. We needed to create a predictive analytics modeling solution, and we also needed to start bringing in interdisciplinary engineers and technologists to help solve this problem. And we created a solution. We deployed it for the first time in 1998, and it's lived worldwide for the past 15 years. And this leveraged some state-of-the-art technology then. We were pushing the envelope, and we're really excited to see that our theories around Internet of Things actually transpired across the globe and actually have hung in there for almost 20 years. And about 10 years ago, I had a really neat opportunity to go work in the embedded products group. And that's the group that is now called Internet of Things. And over the last 10 years, we've had some adjacency opportunities to bring in analytics and really look at how to start thinking edge to cloud. And I'll talk about that a little bit later. And so when we start thinking about machine learning, machine-to-machine communications, and the technologies related to that, basically taking embedded, which is everything but clients and server chips, and bringing it forward, we actually can think about Intel being in the embedded business and Internet of Things business over the last 25 years.
It's such a growth area, and in particular for the federal sector as folks look at it, but initially it may seem complex for agency CIOs and security folks looking at this environment. What can they expect? How do they go about defining it? Is there a simple way to go about this evolution?
To doing that? Absolutely. So when you think about the Internet of Things, you think about it in kind of two main buckets. You've got the edge, and then you've got the cloud. Most people have a good understanding about the cloud, but the edge is a little bit more difficult to understand. To make it pretty simple, it's basically the first point of data ingestion. So you could be collecting data from an actuator in an industrial setting, a cell phone, right in your pocket, or you can also be collecting data on a device. And so that first point of data ingestion, where you can start changing the data from data itself into information, is what we call the edge. And so how does the edge and the cloud actually fit together? Well, there are four main things that actually allow the edge and the cloud to work together. There's connectivity, manageability, security, and interoperability. So to unpack what do those four things mean is pretty simple in itself. Connectivity, how do the different parts of the system interact? It could be like on a Zigbee or a Wi-Fi, or it could be something like LTE, 3G, or the future of 5G. How does that information actually flow? You've got manageability, which is the devices or the edge themselves. How do you actually have those devices discovered into the system? How do you push updates if you need new software? So that whole component piece around manageability is something that has to be planned. Security, one of the fundamentals, is basically the chain of trust between silicon and some of the hardware pieces and the software across the system that glues it together. And then lastly, interoperability. How do all these pieces fit together? When you have those four things, you're missing the wrapper of data. So if you think of data wrapping around this Internet of Things system, what you want to think about is how is that going to actually work in those analytics? And that's when you start putting together your compute strategy. And then with all of these components, edge, cloud, connectivity, manageability, security, and interoperability, and that analytics data wrapper, those are the things that today really comprise the Internet of Things systems.
There's a concept that you're spending some time talking about these days that make this process actually possible, and that's this term called distributed compute. Can you clarify that? What does that mean?
Yeah, distributed compute is basically the methodology around how you're going to change data to information. So one of the differences of Internet of Things is that at the earliest point of data ingestion on the edge, we talk about changing data to information, and that's done through a process called compute. And so instead of having, let's say, dumb sensors, you can actually make them smart by putting some algorithms, analytics, and technology plans in place to actually transfer those dumb sensors to be smart. And so instead of having a sensor being like 4 degrees, 4 degrees, 4 degrees, and sending data constantly up to the cloud, what you can do is make that sensor smart by putting in some kind of algorithm or a threshold monitor that says, hey, only send the data if it's, let's say, 20 degrees. And so what you're doing is you're creating an opportunity for data to move to information at its earliest point of data ingestion, therefore distributing the compute across a variety of edge environments rather than send everything to the cloud for compute. And why is this important is because you really only want to move data around that is valuable to you for the decision that you're trying to make.
Talk to me about some of the experiences, some of the vision, and some of the cases that you've seen that may be applicable for agencies that are now looking at Internet of Things and hoping to achieve value using this technology.
That's a great question. I think the original commercial use cases that I worked on, we saw a lot of value in reducing cost. And I think that's going to be a key tenet across all of the responses. If you're to go out and ask people, why would you do Internet of Things? We want to actually have a value proposition around cost reduction, cost maintenance, time to market of actual solution development. But I think on the flip side, you want to look at some of the less obvious kind of tangible opportunities, which is basically instead of having individuals, let's say, put data into a system, you want to actually have, let's say, machines collecting some of the data and doing some of that hard work for you, so then you can actually reapply the workforce to do something that's of more value. So you think about the workforce, you think about the cost reduction, but you also need to think about better secure solutions. So today in Internet of Things, we actually have an opportunity to increase the security as part of our design principles. So there's a variety of opportunities as well. You also might be able to basically get decisions that you haven't had an opportunity to get to before.
And I imagine the timing of that information is so accelerated. Tiffany Sargent of Intel Corporation, so happy to have you on the program.
Thank you so much. Thank
talking
you.
about this wonderful technology. Thank you. I hope you'll come back on the program and talk about this later. But again, thank you very much.
Thank you
Appreciate
so much.
The conversation.
Hey, thanks again.